Okay, please be sure that you're taking notes because these will be the notes that you have for this section. This section is going to be pretty much a review, as we've done rates before a few chapters ago, and we're just coming back to rates because we can use our algebraic definition of division that we learned recently to go ahead and go a little further with what we already know about rates. So, if you remember back the last time we looked at rates, we talked about how we write rates as fractions, and this represents the amount of A per, remember that fraction bar means per, amount of B. And when we studied this, like I said a few chapters ago, you all listed off a bunch of rates that were common to you. For instance, we talked about miles per hour, we talked about feet per second. All of those are rates. So that's what we're going to talk about, just going a little further with some division. Okay, hopefully this example looks very similar to what we've done in the past. You and a friend drove 400 miles. Your trip took 8 hours. What was your average rate? We could write this rate in two different ways. However, let's write it as we would normally think of a traveling type rate. So if you think of how we travel, we usually talk miles per hour. So let's put our miles information as our numerator over our hours information to get our miles per hour. And we can reduce this, of course, to get a rate of 50 miles per hour. Alright, here's another example that should look pretty familiar. In 1993, total medical costs in the United States were about $884,200,000,000. That year, the population was approximately 257,800,000. What was the average medical cost per person that year? So if you remember, we always want to try to find the rate that we're looking for. So if we look at the question that was asked here, we want medical cost per person. So telling us we want cost as our numerator, persons on the bottom as our denominator. Okay, so we'll take our medical costs per person and again we would want to divide this. So go ahead, take some time, divide this out on your calculator. Hopefully you got an answer of $3,430 per person. So the last two examples were very straightforward. We're just looking for a rate. Alright, this problem actually gives us a rate, gives us some extra information, and asks us to answer a question. The question is, how long? Okay, so reading the whole problem, Becky reads 12 pages per day. At this rate, how long will it take her to read a book that is 190 pages long? So if you remember, we always want our rates to cancel. In other words, we want our labels to be able to cancel, numerator to denominator. Okay? Also, something to remember from the last time we studied this was whatever our answer is, we need to have in the numerator. Okay, so if the question is asking how long, we know that we want time or some sort of label that's going to tell us how long to be in our numerator. Okay, if we look at our rate up above, we have 12 pages per day, and we know 190 pages. Okay, so if we look at the per day, that's probably going to be the how long we want. So to set up our rate, this is actually going to be a reciprocal rate, if you remember that, where we flip the rate. So we'll start with one day she reads 12 pages. So then I get my days, or how long, to be in the numerator. And then we take our other piece of information, 190 pages, and hopefully the labels that we don't want to end up in our answer will cancel, and we can put this over 1. And of course, our pages do cancel, and we end up with 190 times 1, or 190 days, over the 12. Again, we can go ahead and divide this, and if you divide this, you should get about 15.83 repeating days, which we can say is about 16 days. So to answer the question, how long will it take her to read a book that's 90 pages at a rate of 12 pages per day? About 16 days. Alright, this example kind of talks about, so let's read this example. If the temperature goes down 12 degrees in 5 hours, what is the rate of temperature change per hour? There's two ways to look at this problem. I think the rate is pretty obvious. We're going to do temperature change per hour. Okay, so we could do 12 degrees per 5 hours. Okay, and then the two ways we could look at this would be, we could say it went down the 12 divided by 5. So we could say it went down negative, or it's a change of negative 2.4 degrees per hour. So the change again is a negative 2.4 degrees per hour. Or we can say that it went down 2.4 degrees per hour. Okay, so we can either use the word down, or we can use the negative to refer to the fact that the temperature is dropping in some way. So that's how we can use some negatives in the rates as well. Alright, before we move on to our last example, I just want to do some reminding of what 0 does when we're talking about division. So if you remember, if we have 0 divided by 5, that's always going to be 0. If we have 0 divided by 0, that's all real numbers. And if we would have a number divided by 0, that is no solution. Math blows up. If you type it in your calculator, it'll give you an error. So just remember that anything as a denominator can never ever be 0 in math. Using the rules of 0 that we just looked at, let's look at this example. It says, what values can k not have in this fraction or division problem? Okay, we just looked at the numerator can be anything. It can be 0, it can be a number, so the numerator is not at all affected. It's the denominator, the whole k minus 5 part, that can never equal 0. So two ways to think about this. In your head, just think, what can k not be? So, in other words, what can k be to avoid getting 0 as our denominator? Okay, so think about it. Figure out what can k not be so that we don't have 0 in our denominator. This problem was relatively easy to see that if we have k minus 5 and we put 0 in for k, we could get negative 5, that would be okay. We could put 1 in for k, we would get negative 4, that's okay. But if we put 5 in for k, that would give us 0, which we cannot ever have. If all else fails and you can't figure this out in your head, just take your denominator, set it equal to 0, solve for the variable, and that will tell you exactly what k cannot be, because again, we don't want it to be 0. So back to the question, what value can k not have in this problem? K cannot be 5, because it would make the denominator 0.